Number 7. Number 7. A light plane attains an airspeed of 500 kilometers. So, and this is kind of a thing where you got to know what airspeed is for this to make sense.
Oh.
So, right? Yeah. So what do we mean when we talk about airspeed? Speed relative to the air.
No.
It's true. What do you think you would call the speed relative to the ground? Ground speed. No. Right? So, if you didn't know that, A, I will say, you've got Google. B, do you know it now? Okay, cool. So here's what we know. We know that the velocity of the plane relative to the air is 500 kilometers an hour, right? But it doesn't tell us the direction, so I'm just going to write at something, and we don't know what the direction is. All right? It says the pilot sets out for a destination 800 kilometers due north. So that's a displacement, right? Displacement of what relative to what? Plane relative to the ground, right? Because the destination and the takeoff point are presumably on the ground, and those 2 points are 800 kilometers apart. So that's the displacement of the plane relative to the ground. Now, it tells us that the plane is headed 20 degrees east of north to fly there directly. So what does that direction correspond to? Is that the direction relative to the ground or the direction relative to the air? It's okay. So it's got to be relative to the air by process of elimination. It can't be relative to the ground because what direction does he want to go relative to the ground? Due north, right? Okay. The other way you can think about it is this. So pretend that. So the plane is flying. What does it say? It says it's. Why am I dumb? The plane is headed 20 degrees east of north, right? So here's 20 degrees east of north, right? So the plane is flying this way, right? Yes. Good? Now, hypothetically, suppose the wind was just blowing straight east. Would the plane be moving in this direction, the direction it's pointing in? No. No, it would be moving, right? You see what I'm saying? It would be pointing in one direction, but not necessarily moving that direction, because the air is moving it additionally. Follow? Yep. So that 20 degrees east of north is the direction that the plane is headed relative to the air. Follow? Okay, now, what else do we know? It says the plane arrives in 2 hours. Why do I care about the time? What do you got, Peter?
Because if it arrives in 2 hours, then that means that your speed relative to the ground could be your 800 kilometers over 2 hours.
Exactly. So I can combine this information to find out that the velocity of the plane relative to the ground is 800 over 2, so 400 kilometers an hour due north, right? Everybody good up to there?
Yes.
Okay. Finally, the question says, what was the wind velocity relative to the ground? So we're looking for the velocity of the air relative to the ground. Cool? All right, so here's the deal. This is, I think, what I did not do a great job prepping you guys with on the notes. All right? I stressed the importance of this equation, right? That's why it's been on the board for the last 3 or 4 days. Okay? So what we want to do is we want to write an equation using these variables that looks like this. Okay? And in helping people, one of the things I've discovered you can do is this. Look. And to those of you who have come in before after school, I apologize, you've heard this before. All right? So forget about this for a minute. All right? Suppose I'm looking for the velocity of A relative to B. Okay? Suppose that's the thing I'm trying to find. Well, automatically, I know that that is the exact same thing as the velocity of A relative to any other object, plus the velocity of that other object relative to B, right?
Yeah.
So that allows me a way to find the velocity of A relative to B, right?
Yeah.
So in this problem, I'm looking for the velocity of the air relative to the ground. Oh, well, that's equal to the velocity of the air relative to, what's the other object I care about here? The plane. So this is the velocity of the air relative to the plane, plus the velocity of the plane relative to the ground. Awesome. Now I have an equation that I can use to help me find the thing that I'm missing. This is huge, you guys. I cannot understate the importance of this. When you're dealing with relative motion, you have to come up with this equation. Is everybody good with that? All right, great. So what the bleep does this have to do with all of this? All right, well, the velocity of A relative to G is the thing that I'm looking for. Let's see. Oh, shoot. I don't know the velocity of A relative to P. Right? Look at the things I know. I know this, and I'm looking for this. So look, I don't know the velocity of A relative to P, but I do know the velocity of P relative to A. Oh, well, that's negative. Oops. So that's negative VPA, right? Plus, do I know the velocity of P relative to G? Oh, right on. I know that. Cool? Any questions?
Wouldn't be negative V?
Wouldn't what be what?
The first, the velocity of the plane relative to the air.
This?
Yeah, wouldn't it just be like, isn't that negative? Like,
So VAP,
no, right, I know it's the opposite, like because it's the other direction, but when you write it like that, wouldn't it just be the negative of the velocity of the air relative to the plane? Like when you wrote in that equation again, when you wrote the negative in front of it, isn't that like
so my goal was to get this equation, right?
right, yeah, I get
And
that.
do you agree that this is equivalent to this?
Oh, yes. I thought you were trying to say that to find that thing, we need the opposite
I gotcha.
of the first one. I did. You just wrote it the other way of what I was
Yes. You're good?
Yes.
Is everybody good? Okay, so now what I'm going to do is I'm going to write in vector notation each of these vectors.
I don't like vectors.
I'm sorry. It's not going to go away. If you don't like vectors, you don't like physics, because like legit, because they're not going to go away. All right. So let's do this. So let's write an expression for negative velocity of P relative to A. All right. Well, that's going to be 500 kilometers at, instead of 20 degrees east of north, it's actually 20 degrees west of south, right? I want to flip it around 180 degrees, right? Does that make sense?
Yes.
All right, so now what I'm going to do is I'm going to write that out in unit vector notation. So negative VPA is, so 500 sine of 20. So you get 171I and you get 469.8J. Should either of those be negative? Both of them should be negative. How can I figure that out without even drawing the triangle? West and south, right? So that, what I just wrote here, is this thing, right? Good? Johnny, how you doing back there? You all right?
Yeah.
Somebody remind me to mark cutty apps, and I forgot to do that. All right. Everybody good? All right. Now, I also need to know the velocity of P relative to G. Oh, that's over here. How do I write that in unit vector notation? Just 400J, right? Cool? Now what do I do? Add them, right? Because we decided that the velocity of the air relative to the ground was negative VPA plus VPG. So add them up. So now the velocity of A relative to G is going to be negative 171I minus 69.8J. And now you just put your vector back together. Yes, Peter.
So, oh wait, actually never mind. I thought that because when I did this problem, I was trying to make like the total like y-axis vector quantity 400, because I thought that like with everything ended up together that it would equal 400.
There is a way to solve it that way.
Yeah, and like that's what I tried, but then it just like didn't work out, and now I'm confused.
Okay, so what I'm hearing you say, you tried to make everything add up to VPG, is that correct?
Yeah.
So, let's do that then. If we want everything to add up to VPG then, this should have been your expression. The velocity of the plane relative to the ground should be the velocity of the plane relative to the air plus the velocity of the air relative to the ground, right?
Yep.
Okay, so let's see, which of those two things do we know? We know the velocity of the plane relative to the air. Oh, actually, this works. This is cool. So, the velocity of the plane relative to the ground was 400J, right? Is that correct?
Yep.
Equals the velocity of the plane relative to the air. That's this, but with my signs flip-flopped, right?
So it'll be positive.
So that's 171I plus 469J plus the velocity of the air relative to the ground, which is the thing we're looking for. So this is cool.
Oh yeah.
So now what do you do?
I neglected to acknowledge the fact that it would be a negative quantity, like that DAG would be a negative quantity, as far as like the J goes,
Gotcha.
the J component. So
Yeah, it would be negative 69,
so when I
right?
got 469, I got discouraged because I was like, how could it end up to 400 if I'm already above 400?
I gotcha. Good. So yeah, this works. That's good. Yes, Carla.
So, okay, it's kind of weird, but instead of like adding velocity vectors, I like,
Did it using the displacement vectors?
Yeah.
You can do that. I think it's ugly, but it works.
yeah, and then like, how do I find an angle? That's what I got the right velocity.
It should be the exact same thing because your displacement vectors are always going to be proportional to your velocity
Okay,
vectors.
so let me try again then.
So it should be the exact same thing. You should get exactly twice because the time was 2 hours. So all of your numbers should just be twice as big as mine.
Yeah, I divided it by 2 hours for the velocity. So I got the velocity, but then I just couldn't get the data.
Okay. All right. Are we good? Questions? All right. So this technique, you guys, this technique of writing out an expression like this is colossal. Like you can't do these if it's about a boat crossing a river or a plane in wind or a ladybug crawling across a conveyor belt or anything like that where you've got one thing moving this way and another thing moving that way. You got to do this. Follow? All right, and I think what I didn't do a good job of in the notes is showing you once you do that, then how do you add the vectors, right? And that's, you got to do the unit vector notation or components, right? Good? All right, so 8 is very similar to that, okay?